Today's our first question is minimum cost climbing stairs. So we have given a cost array. We have to find the minimum cost to reach the end of the array or to reach the size of the array. Okay, in the minimum cost. Okay, so let me take a test case given the first test case is 10, 15, and 20. So we can move one step or two step at a time. It's totally depend on like what we gonna choose the next to get the minimum cost. Okay. So first of all, we will start from the zeroth index. Okay. So we can go to 10 or we can go to 15. We have two steps. Okay. So if I go to 10, then I have to go to 20. I can go to the maximum 20. Then my total cost will be 10 plus 20, 30. Okay. But now I can go to 10 or 15 at my first in my first iteration or in my first step. So if we choose 15, then after 15 we can go to 20 or we can reach the end. So we will jump two times from the 15 to reach the end of the array. So the minimum cost will be 15. So how we can apply to this our code? So first we will go through the recursive solution, okay, and how we can approach this question. So what is given to us is we can start from either 0 or to 1 and we can climb one or two steps, okay. We can start from 0 to 1 and we can climb two step or one step. And each step has a cost given to us and we have to minimize the total cost to reach just beyond the last step. We have to reach the just beyond the last step. Okay, so how we will do is with a brute force solution, or we can say a greedy solution or a recursive solution. So first we will introduce a new function called a recursive function. So we will make a recursive function. So how you can think of this question by just going to the topics and there is written dynamic programming. Okay. So in dynamic programming, first go to the recursive solution because by approaching the recursive solution, if you can achieve that solution, then you can memoize it and or tabulize it. So the first approach will be the recursive. In recursive function, we will just give the parameter or argument our coast array and a integer index. So we will just give the index as size of the coast array. Okay. And we will call the recursive function in our main function by just passing the length of the array and the array itself. So what is given to us is we can either start from 0 or from 1. So if we start from 0 or from 1, we have a cost 0. So this will be our the best base case. So if you are going through a recursive approach, then you just have to think the base case first. Okay. So if you got the base case, then the question will be in your hands. So at the step 0 and the step 1, we have no cost or we can just return the 0. As stated in the question, to move further, just go through the question. We have two options. Okay, we have two options. The first option is the first option is we can we can just we can just take the first step or we can take the second step. Why we are decreasing? Because we are going from the last. Okay, so it is the approach where we iterate or we recurse the array from the last so that when we tabulize our code, it can be easy for us to tabulize it. Let me explain how we are going through our question, how we will gonna solve our question. Okay, so this is our array given to us. Okay, so we have the steps are followed as 10, 15, and 20. So if we iterate from the last, so what we can say is we can just take the value 20 as our first value and 15 as our second value. Okay. When we add 20 in our solution or in our, like you can say in our calling stack, we get the 20 and we are getting the 15 and we will choose the minimum of them, what we have to take. So if we are getting a 20 and we are getting a 15, we will choose the 15 because it is lesser than 20. So that when we reach to the zeroth index of the array, we will return a 0 because when we reach to the zeroth index, we are reached to the end. Okay, we are reached to the end, so we will return just 0. So how we will gonna do this as recursive? So let's come to our question. So we have just added the first step value and the second step post. Okay, first step post and second step post. So we have to take the minimum cost. Okay, so how we can define the minimum cost? Okay, the minimum cost will be minimum of first and second. Okay, then we will just gonna return the minimum. So this can be our approach, and how we are going through recursion in this problem is we will just iterate or we will just recurse the array to the index 0. If we are taking the step 1, then we will recurse this array. We will just go to the n minus 1 every time in the first, and in second we will just go n minus 2. Then, okay, there is a blunder. It is an index. Now, this is our code of recursive approach. So, if we take the dry run of this code, if we're gonna do this, we will just start from the last index, that is 20. Okay, and we are taking 0 as our base case when we are reaching to the index 1 or lesser than 1. Okay, okay. If we are choosing the first case when we are going through the first step, that is 20, the first index. Why we are doing index minus 1? Because we are going through the n and n is out of the bound. So we have to be in bound. So we are taking index minus 1. Okay. So when we are doing index minus 1, then we are at 20 at the first iteration. Okay. So after recursive calling of a function, we will just go and see how we gonna call. Hello. So we have a question of going to 0 to the end of the array. Okay. So we were iterating from the last of the array. So from last we have cost 0 at the first. Okay. We can go to 15 or we can go to 20. As you can see in array, we can go to 20 as our first step or we can go to 15 in our second step. We will choose to go to 15 because it has the minimum cost. So if we are going to 15, okay, as our first step or you can say first recursive iteration, we will go to 15. Why we have chosen 15? Because 15 is lesser than 20 and 15. If we compare 20 and 15, We will choose 15. So from 15, either we can go to the 10 and either we can reach the end. So if we take this approach, then we get the result as minimum result as 15 because we are just going to 0 to 15 and 15 to end because we can choose the 15 as our first step as like we are iterating from the last and at the last we have cost 0 in our hands. And when we are choosing not 20 and 15, we have 15 cost in our hand if we add the cost. Then, after going from 15 to the 10, we have to jump again to reach the end. But we have a option of going 15 to directly end of the array because we have the option of going through two steps at a time. Okay, so after 15, we will reach the end, or we will reach the first of the array. We will reach the zeroth index, and if we reach the zeroth index, then we are reached to the our solution. So this will return the minimum cost we will get. So I hope if you like this question. If we talk about the memoization of this approach, we will just make a array DP. In DP array, we will just gonna fill the -1 to the and fill in the blanks. Okay, how we are solving it by using DP? So we have the same base case as we have in recursive approach. We will just return the 0 if we reach the end or if we reach the first index. We will fill the we will fill the minimum of 1 and 2. We have taken the first and second in our recursive approach. So we will fill the n minus at the n minus 1th index of DP, the minimum of first and second. So we have our minimum costs at the indexes in our DP. So if we gonna reach at the index where we have already filled the minimum cost, we will return the value lies in that index. Okay. If I talk about the tabulation approach of this question, then we have our base case as we will just fill our recursive base case into the array which has length of n plus 1. So at the 0th index we will fill the 0 and at the first index we will fill the 0 because in our recursive approach we have taken a base case of if n is either 1 or less than 1 we will return 0. So in our tabulation approach we have just filled the dp of 0 and the first index as 0. So in this approach, we are going from left to right in the array because as I said in recursive approach, we will iterate through the last index of the array to the first index of the array. That will make our tabulation approach easy to think and we will go from the left to the right and which will easier to think and it is a easy approach. Okay, we will just gonna fill the minimum of either our first test case, okay, our first condition, the first step or our second step to dp of ith index, and we are iterating from 0 to n, okay, and we are including n because we have made the length of the dp n plus 1, so we have reached the end, and when we reach the end of our dp, we will get our solution as the minimum cost of the. So if we go through the visual, then we have just put at the base case in our DP and we have taken the DP one length greater than our original cost array, which has the length of 3 and we have taken 4 length in as our DP. Okay. So in our 0 and our first index of DP, we have filled 0 and 0 because it is our base case as we have written in our recursive approach. Okay. So it is the function or it is the code of iteration into the, like you can say, dp. When we are at the index I equals to 2, then so when we are at index 2, so it is our index 2. When we are at this index, we will fill the dp of I. It means we will fill in dp as our dp of I minus 1. I minus 1 is 0, and the cost I minus 1, the cost I is 20, because at the second index we have 20, and if we just subtract 1 from 2, then we will reach to the 15. So 0 plus 15 is 15, and if we like see the second option of dpi minus 2, that is 0, and cos I minus 2, that is 2 minus 2, that is 0. If we take 0 comma 10, 0 plus 10, then it will be the minimum of, if we compare 15 and 10, then we will just write the 10 here. Okay, we have just written the 10 because it was the minimum. Okay, then at the second iteration, when I is equals to 3, and when I is equals to 3, we will just fill in the dp of 3. What we will fill is minimum of dpi minus 1. What is dp of I minus 1? 3 minus 1 is 10, and cos I minus 1, 3 minus 1, that is second index, and at our second index we have 20. So 20 plus 10 is 30, and at our dpi minus 2, what is our at our dpi minus 2 is 0, and what is at our cos I minus 2 is 15. So 0 plus 15 is 15, and if we compare 20 plus 10, 30 to the 15, we will choose 15 because we are doing the minimum. Okay, so we will just try the 15 here. Okay, so we got 15 at our dp of n. So what we were returning was dp of n, and this was our answer as written in the question. Thank you so much. If you enjoyed the video, just subscribe the channel. And as I'm new here, so don't worry. The videos will come frequently, and I will just add the videos as I solve another problems, and I will do my best to make you understand the problems easily, because like I am also learning, and I am also a student right now. If you find the video helpful, then please like and subscribe the channel. Thank you.